Hey guys, welcome back to my YouTube channel. Today we're going to be talking about acids and bases. Acids and bases are a fairly big concept in chemistry because it has a lot to do with a lot of the reactions we have and as well as a lot of the substances we have. And so we're going to be talking about really two things regarding acids and bases. First, we're going to be talking about how we define it, and then we're going to talk a little bit about how we measure the intensity at which the acid or the base does what it does, because not all acids and bases, and not all acids and not all bases do the thing that they do to the same extent. Some do it to a greater extent, making it a stronger acid or stronger base. So first, for the definition, so we have three definitions. We have the Arrhenius definition, the Bronsted-Lowry, and the Lewis. These are in order of sort of when they were came up with. They weren't all came up with at the same point in time. There was, scientists who sort of came up with them at different points in time, and this is the order that they were came up with. Another thing to note before we talk about what the actual definitions are is sort of the exclusivity of each one of them. So the oldest one, Arrhenius, is the most exclusive, and Lewis is the most inclusive, and Bronsted-Lowry is kind of like in the middle. So what that means is that every Bronsted-Lowry acid, so every Arrhenius acid is therefore also a Bronsted-Lowry, and then every Bronsted-Lowry is also a Lewis, but not every Lewis is a Bronsted-Lowry, and not every Bronsted-Lowry is an Arrhenius. So that's a little bit of talk about the trends in the definitions. But what are the definitions? The definition of Arrhenius acid. So Arrhenius acid, unlike the other two, is confined or restricted to aqueous solutions, meaning water. And the definition of Arrhenius acid is any substance that produces hydrogen ions when placed in water to some extent, which naturally, so hydrogen, what is that? Let me write it out. What is that? That's basically this. It's just a single proton. If it was a proton and like an electron or whatnot, they would just be neutral, so it wouldn't have the charge, but it's just the proton itself, so that's why we put the charge for the plus. And that's what an acid is. An Arrhenius acid is any substance that when you dissolve it into water, it dissolves into either one or more of the hydrogen ions, and then also it's like conjugate base, which is what it becomes, the other part of it becomes. But naturally, what actually happens is while it does produce hydrogen ions, what it actually happens is we'll produce this, hydronium ions, just because the hydrogen ions in nature are so reactive in the water that they just don't stay that way, that they combine with the water molecules to create this. And then that's what Arrhenius acid is. Arrhenius base is anything that produces hydroxide ions, which is this, OH minus, when placed in water. So then we're talking about Bronsted-Lowry. Bronsted-Lowry is a little different. It's not specifically confined to water aqueous solutions. A Bronsted-Lowry acid is anything that is a proton donor. By proton donor, I mean, where is it? This hydrogen ion donor. And a Bronsted-Lowry base is anything that's a proton acceptor, right? So one donates, one accepts. And then the Lewis is the last one. Lewis acids are anything that's an electron pair acceptor, and a Lewis base is anything that's an electron pair donor. So it's a little bit backwards because, the Bronsted-Lowry, you have the acids being the thing that is donating, and then Lewis, you have the thing that's accepting, right? So it's a little bit backwards. So the first two, of course, deal with hydrogen ions, and then the third one doesn't. And then one more thing to note before we talk about how we quantify the intensity at which acids or bases could do what it is they do. We have to talk about neutralization reaction, which is neutralization reaction is basically whenever you take acids and bases and put it together, they neutralize each other, where so let me write this out. So the acid, of course, will produce this right here, the hydrogen ion, and the base will produce this, the hydroxide ion. What happens is that the sort of conjugate base of the acid and the conjugate acid of the base, those are just fancy words for saying like what the acid of the base becomes after it sort of releases what it's going to release. they come together to form a salt, thereby neutralizing each other. And they also, these two things are here combine to make water, because water is H2O, and you got one H here, one H here, one O here, and you got a positive and minus here, and you put together this neutral. So that's kind of like what they are. So let's talk about strengths of acids and bases. Not all acids and bases are the same strength, quote unquote. By strength, what we mean is the extent to which they dissociate. The extent to which they dissociate. So strong acid or strong base will dissociate completely. So they will like dissolve completely. They'll separate into their two parts. And a weak won't do it as much. It'll do it some, but it won't do it as much, and that can be affected by a few things. So what we have right here, I wrote it down here, Ka and Kb. These are just this is just another way of measuring the intensity, the official intensity at which certain substances will dissolve, will disassociate into its constituent parts. The greater the value, the stronger, the more readily it will release hydrogen ions or hydronium ions. Therefore, the greater the acid or the greater the base is. Right? And really what it is when you write it out, which is like the equation, it's just basically the products over the reactants, or the concentration of products over reactants. pH and pOH, these are, of course, so the Ka corresponds with acid and Kb corresponds with B. pH is a way of measuring a solution's acidity, and pOH is a way of measuring a solution's alkalinity. So these two have to do with more with specific compounds, and these two have a little more to do with solutions. They are related to each other, like, they are related to each other, but they can be different because a solution is a little different from an individual molecule. And then there's a couple other ways. So so water is neutral. It's neither an acid nor a base, though it can behave as either or. And this is sort of an equation representing the fact that, or quantifying the amount to which water will by itself auto-ionize, where basically the water molecules, the H2O molecules, out of every, I think it's like a billion or something water molecules, they will be one that auto-ionizes, and they do it in equal proportions to each other. By that I mean it just naturally will produce this right here is the acids part, and this is the base part. It automatically produces the hydronium ion and then hydroxide ion, but this is random and kind of meaningless, except for the fact that you can use this in calculations to determine a large number of things. So I guess it's not meaningless. And then last but not least, just wanted to point out another way we sort of quantify acids and base strength is this percent ionization thing. And the idea is it's to produce a percentage out of 100 of the extent at which it dissociates. So as you can see, the way you calculate it is the concentration of ionized acid over the initial concentration of acid. I think that's it. Please like and subscribe. Yeah, that's it.